Okay, we're back with fractions. So this is covering sections A4 and A5 in the appendix. So fractions, pretty straightforward. The first very basic one is how do you add 1/2 plus 1/3? They don't have the same denominator. I always do something that I just call the bow tie method, which is beep, boop, there's my bow tie. So 1 times 3, keep the plus sign. 1 times 2 is 2. 2 times 3, that's 6. So 5/6. So it's pretty easy. This times this, keep the sign. This times this, that's your top. And then multiply across the bottom. So another example, 11/12 plus 7/20. What's that going to be? Well, boop, boop, boop. 11 times 20 is 220. 12 times 7 is 84, and then you multiply across the bottom, and that gives you 240. So this becomes 304/240. Of course, this is not in lowest terms. The big bugbear here is how do you simplify that? And simplifying is actually pretty straightforward because it's just sort of cancellation. These are just numbers. What can you take out of both of them? Well, you can take out a 2. That's always a good place to start. 304 is twice 152. 240 is twice 120. And you can cancel the 2's. 152 now is actually 2 times 76. 120 is 2 times 60. So you can cancel the 2's again. These are both even, so you can factor out another 2. 76 is 2 times 38. 60 is 2 times 30. Cancel out the 2's, and we can do it one more time. 38 is 2 times 19. 30 is 2 times 15. Those can be canceled. So at the end of the road, what do we have? Well, 11/12 plus 7/20 is 304/240, and after we canceled everything out, we get down to 19/15, and there's nothing else that we can cancel out. Okay, that's a little bit tedious, canceling out all those 2's, but one benefit of this bow tie method is that you get to a fraction, 11/12, 7/20. You can get to this fraction pretty quickly, and then you have to do a lot of cancellation. What about trying to simplify it first? So what we actually have is that our denominators, 12 and 20, are actually divisible by the same thing. So what's 11/12 plus 7/20? We can write this as being 11/4 times 3 plus 7/4 times 5. So you look at the denominator here, it's got a 4 and a 3. This one's got a 4 and a 5. The 4's are common. This one has a 3, but this one doesn't. This one has a 5, but that one doesn't. So we'll fill out the denominators. Multiply this one by 5/5. Multiply the second one by 3/3. Now my denominator is 4 times 3 times 5. 4 times 5 times 3, same thing. So it's 55, and that's 5/11 over 60, plus 21 over 4 times 5 times 3, which is 60. Now whenever you have the same denominator, here's a 60, and here's a 60, two fractions, same denominator, you can combine them into one fraction over that denominator. And 55 plus 21 is 76. And note that 76/60, we got that here. And so this will be 19/15 after you cancel out a pair of 4's. So you can find what's called the least common denominator, in which case that's 60. But you still might have to do some more canceling to get it into lowest terms. Okay, so that's our numbers, fractions involving numbers. What about fractions involving variables? Oh, I have one last thing about fractions involving numbers. Sorry. What about 7 divided by 2/3? What's that equal to? Well, whenever you're doing division by a fraction, you have to multiply by the reciprocal. So 7 times 3 halves, 7 over 1 times 3 over 2, that's 21 over 2. And the reciprocal of fraction is just, flip the fraction. So this is 2 over 3, its reciprocal is 3 over 2. And if you have a fraction in the denominator, you have to flip it and then multiply by what the flip thing is. Okay, and we'll see that again in a little bit. What about some variables? Well, it's the same sort of deal, right? 5 over x minus 3 minus 7 over 2x minus, oops, let me make that x a little tidier, 2x minus 4. Well, same thing. Boop, 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 bow tie. So we get 5 times 2x minus 4, that's this times this. Keep the sign, that's the minus sign. And then we have 7 times x minus 3, that's this times that. And what is that over? X minus 3 times 2x minus 4. So there it is. And now we just have to multiply it out and clean up the top a little bit. Distribute the 5, you get 10x minus 20. Distribute the minus 7, you get minus 7x plus 21. And that's going to be all over x minus 3 times 2x minus 4. So what do we have at the end of the road? In the top, 10x minus 7x, that's a 3x. Minus 20 plus 21, that's a plus 1. In the bottom, what do we have? Well, I'm going to be a little tidy here. I'm going to take this factor of 2 out of this one. So we'll have a 2 times x minus 3, and then x minus 2, right? If I take a 2 out of 2x, I'm left with an x. Take a 2 out of a minus 4, you get a minus 2. And there's nothing to be canceled there, and so that's done. So that's not too bad. We can look at a slightly grimmer example. X squared over x squared plus 5x plus 6 plus x plus 9 over x plus 3 plus, nope, not plus, but minus 2. And what we want to do is make this one fraction. So how can we go about doing that? Well, we could bow tie here, right? This fraction and this fraction, but that might just get horribly messy. And then we have to deal with the minus 2, so there's 3 of them. So what we're actually going to do is, well, we know how to factor this. Right? X squared plus 5x plus 6, as we saw last time, you can factor that into x plus 3, x plus 2. Right? 2 times 3, that gives me the 6. 2 plus 3, that gives me the 5. And then we still have our x plus 9 over x plus 3 and a minus, let me give myself a little space here, and a minus 2. Okay, so looking at these, this has got an x plus 3 and an x plus 2 in the denominator. This is just the x plus 3. This doesn't have any of them. Technically, 2 is 2 divided by 1. So it's got a 1 in the denominator. So what do I need to make sure that I have the same thing in all the denominators? Well, the middle term is going to have an x plus 2. So I'll multiply by x plus 2 over x plus 2. And then I'm going to put in parentheses everywhere just to be careful about what I'm multiplying, right? I'm going to have to do a distribution here. And then this one, the minus 2 over 1, well, to get a denominator of x plus 3 times x plus 2, I have to get an x plus 3, x plus 2, and an x plus 3 over x plus 2. Great, and so now all of my fractions have the same denominator. The tops need to be tidied up a little bit. But let's first rewrite this. I have an x squared from here plus x plus 9 times x plus 2. Oops, times x plus 2. And then minus 2 times x plus 3 times x plus 2. And that's all going to be over x plus 3, x plus 2. And this really isn't as ugly as it looks because you just have to multiply everything out, right? And it's just a lot of distribution. So we have x squared plus, right? Deal with this. X squared, that's x times x, plus 2x. 9 times x, that gives you 9x. 9 times 2, that gives you plus 18. Here we have minus 2 times x plus 3 times x plus 2. I'm going to multiply these two. Oops, don't know what's going on there. I'm going to multiply these two together first. And that's actually x squared plus 5x plus 6. And I'm going to leave the denominator till later. We'll just leave that like that. Excellent. Great, so now we can finish this up. We have x squared plus x squared, that's 2x squared. We have 2x plus 9x, that's an 11x. We have a plus 18. We have a minus 2x squared. We have a minus 10x and a minus 12. And this is all over x plus 3 times x plus 2. Okay. The 2x squareds cancel out. I have an 11x minus a 10x. 11 minus 10 is just 1x. Plus 18 minus 12, that's a plus 6. X plus 3, x plus 2. Nothing cancels. So we're done. So what's going on here? Well, I have a kind of complicated, if we come back to the original problem, we have a kind of complicated three-term thing. I want to get all the denominators to be the same thing, right? This one is x plus 3 times x plus 2. This one just starts out with an x plus 3, so I have to multiply by x plus 2 on the bottom, which means also multiplying by x plus 2 on the top. This one starts out with a denominator of 1. It doesn't have an x plus 3 or an x plus 2, so I've got to multiply top and bottom by x plus 3 over x plus 2, and then that gives me the same denominator and just simplifying the top. Okay. So there's something involving some polynomials. Last, fractions in fractions. So how do we simplify something like 1 plus 4 over 3x divided by 7 plus 3 over x? What is that equal to? Well, there's my division. 1 plus 4 over 3x, that's the top. I'll put that in a big parentheses. 7 plus 3 over x, that's in the bottom. We'll leave that also in a parentheses. So now we just need to add these suckers together. Any number like 7 is a fraction. It's 7 over 1. And you can write it like that just to sort of simplify it. We just need to, not to simplify, but just to make the notation a little clearer, because we'll just, bow tie both of these suckers. So I get, for the top, 1 times 3x is a 3x, plus 1 times 4 is 4, 3x times 1 is 3x. For the bottom, 7 times x is 7x, 3 times 1 is plus 3, keep the plus sign there, and then 1 times x, that's x. Great. And now we have a fraction over fraction. Multiply by reciprocal exclamation point. So what do we have here then? Well, we'll take the numerator, that's the thing on the top, and we'll multiply it by what we get if we flip this. So an x on the top and a 7x plus 3 on the bottom. Multiplying fractions is easier than adding them. You just multiply across. So I have 3x plus 4 times x over 3x times 7x plus 3. So what can be canceled here? Well, you can only cancel things that are multiplied together, right? So I have this whole thing times x, and I have 3 times x times this whole thing. So I don't have a 3x plus 4 on the bottom, so I can't cancel there. I don't have a 7x plus 3, in the top, so I can't cancel out the 7x plus 3. I do have an x here and there, so those can go away, but I don't have a 3 in the top. I have a 3 that it's inside here, right? But this whole thing is multiplied by something, so I can't cancel there. So I've got 3x plus 4 over 3 times 7x plus 3. And there's no more cancellation that we can do there. If you wanted, you could multiply the 3 in and get a 21x plus 9 on the bottom, but there's not much. And when you're looking like something like this, this is added in the top, this is added in the bottom. There's no cancellation that can happen here. You can't cancel when things are just added together. They have to be multiplied together, right? Something times x, 3 times x times 7x plus 3, and you can cancel out the x's. So, and that gives us the way to handle fractions and fractions. One last example of that, 1 plus 3 over x divided by x minus 9 over x. What's this? Well, 1 over 1 plus 3 over x over 1, oh, just a 1 there, minus 9 over x, parentheses, parentheses, everywhere parentheses. Parentheses are your friend in math. So, quick bow tie here, quick bow tie here. X times 1 is x plus, keep the plus sign. 3 times 1 is 3. X times 1 is x in my bottom. X times x is x squared. Keep the sign, so it's a minus. 9 times 1 is 9. X times 1 is x. So how do we handle that? Well, take the top, just rewrite it, and multiply that by the reciprocal of the denominator. So x over x squared minus 9. And so that's x plus 3 times x over x times x squared minus 9. And I'll tidy this up a little bit. That's times x. So this times that over this times that. And this x and this x can cancel out. And it looks like we might be finished. Right? X plus 3 over x squared minus 9. This can be factored, though, in the denominator. It's x plus 3 over x plus 3 times x minus 3. So now we have something else we can factor. Right? X plus 3 times 1 in the top over x plus 3 times x minus 3. This whole thing can be canceled with that. And finally, we're left with 1 over x minus 3. And that is, right, if we just remember what we started with, 1 plus 3 over x minus 9 over x. So there's some basic fractions. And again, this is sections A4 and A5 from the appendix in the book. Okay, so thanks for that. And then we'll move on